Hello, everyone, and welcome to St. Andrew's Institute of Technology and Management, Gurgaon, Delhi, NCR. St. Andrew's Institute of Technology and Management is the best college in the northern India, and it is the fastest upcoming college of the entire country. It offers a variety of courses from BTech, BCA, BBA, and soon starting with MBA, Architecture, and Law. It provides 100% placement and job assistance. It provides very nice trainings for the placement purposes. This is one of the best college that you can take admissions into. This is the best career choice that you can make for yourself or for your children. Here we discuss the subject principles of software engineering. Code is CSE 302F. This is a CSE 6 semester subject and the syllabus is in accordance with AMDU University Rohtak. Now this is the fifth lecture into the unit number 3 lecture series of PSC. The topic we shall be taking in here are system testing, that is recovery, security, stress and performance testing. Right? So we'll discuss it all one by one. First we come to system testing. So what is a system testing? A system testing is a level of software testing where a complete and integrated software is tested. The purpose of this test is to evaluate the system compliance with the specified requirements. System testing done by a professional testing agent on the completed software product before it is introduced to the market. So what it means, like you are testing and whatever that you are testing, so that you are testing as a whole system, right, the entire software. So that's why it is known as a system testing, because you're entire testing the software system. Before this we have discussed unit testing and performance testing and acceptance testing, unit testing, acceptance testing, integration testing. So this is in the third place, like unit integration and system testing, right? So this has two categories, like we discussed this previously also: black box and white box testing. System that falls under the black box testing category of software design, right? And white box testing is testing of the internal working or core of the software application. In contrast, black box or system testing is the opposite. So you are not concerned with the internal, right? And the system test involve the external working of the software from the user's perspective, right? We have already discussed this black box and white box previous lectures also. Okay, so how do we actually do a system testing? See, so first we set up an environment, like a test environment setup we do, that is create testing environment for the better quality testing, right? Then we create test cases. So after making the environment we create test cases. Then we create test data, that is generate the data that is to be tested. Then we execute test data, that is after the generation of the test case and the test data, test cases are executed. And defect reporting, that is defect in the system are detected. In regression testing, it is carried out to test the side effects of the testing process. Log defects are fixed up in this process, so you fix up all the log of the defects, right? And retest, that is again you put it through the same process. It's so simple. So see, it is clear from the figure also. You set up a test environment, then you generate the test cases, you generate it corresponding to the particular test class, you generate the testing data. So different cases, it can be the different data, or you can test to it depends upon to your module, right? Then you execute those or you run those kind of test cases, then you report the errors, then you do a regression testing like very high and with very speed. Then you do the log effects and defects, and then you reset it to continue the cycle, right? So what are the types of system testing? The very first is the usability testing. So this mainly focuses on the user's ease to use the application, flexibility in handling controls, and ability of the system to meet its objective. Load testing is necessary to know that a software solution will perform under real life loads. Regression testing involves testing done to make sure none of the changes made over the course of the development process have caused new bugs, right? So you do regression, like first you tested, you did the usability testing, you did load testing under various load. So regression is one of whatever the changes that you have made, so you just do a very fast S2 this, like it has not introduced any new bug, right? Removing the older. In order to remove the older, you have not actually put up a new bug. Then you have a recovery testing. This is done to demonstrate a software solution is reliable, trustworthy, and can successfully recover from possible crashes. So migration testing is done to ensure that the software can be moved from older system infrastructure to the current system infrastructure without any issues. In functional testing, what you do functional, this involves trying to think of any possible missing function. So testers make a list of the additional functionalities that a product could have to improve it during the functional testing. Right. Then you hardware software testing, that is the tester focuses mainly his attention on the interaction between the hardware software during this testing. Okay, performance testing. So if you do a kind of a performance testing out on to test the speed, the scalability, stability, and reliability. So how the system is performing under various matrices. You see you have different matrices. Like you such as many subjects also, you study your data structures, you study your algorithms, and you did your OS. So there were different kind of parameters that were there, and therein you computed actually the complexity of the algorithm, or you were looking basically at the kind of like how it's performed. So what are the matrices that basically you do to say that this is a nicer performance and this is not. So you carried out a various number of matrices, and these are speed, scalability, stability, and reliability. So there are various number of test cases that you run, and you actually compute the performance of them. Load testing. So this is under various behavior of the system, that how it is performing under various loads. Okay, your stress testing, that is done to see the robustness. So what you do in stress testing, you actually fail the system, and when the system fails, you actually see that how it behaved, right? So the scalability is carried out to check the performance, like how the application will perform if you really scale that thing up. You scale the existing capabilities of the software, and you scale the user load. So these are all interconnected with very smaller differences, that just a one or two kind of differences has kept a segregation between them, right? Okay, next we come to recovery testing. So what exactly is a recovery testing? So anything, see the name suggests recovery testing. So what exactly is recovery testing? Is something has gone actually into the system, and that something is the one that is actually you want to recoup from that, right? So you want to you want to recover from actually that. So the word recover comes that you have already been into the pit, say, and you want to come out of it. So that is a recovery testing, right? So how you look at this, right? So recovery testing is a type of non-functional testing technique that is performed in order to determine how quickly the system can recover after it has gone through system crash or hardware failure, right? So your system has crashed, or any hardware fault has taken place. So after this, actually the hardware failure and the system crash, how your system is recovering from it. So that is actually the recovery testing is doing, like how we'll be able to recover, how the system will it happen on its own, or it really requires a user interactions, or it triggers onto some various parameters. So that is entirely the area of recovery testing, right? That is the first failure of the software to verify if the recovery is successful. So if like your system software recovers, then you can say that your recovery testing is a very nice performance it is showing. But if it can't, then you need to improve your recovery testing, right? So what are the plans? Like how do you do it? What are the various steps that you actually carry out this recovery plan? You determine the feasibility of the recovery process. First you see that this is feasible or not, right? So anything that is not feasible or cannot actually, you cannot evaluate anything on the basis of that is impossible, right? I cannot say that you are shorter or taller based on to my distance from here to moon. So that is not a kind of a feasibility kind of a sort of stuff, right? So first you have to see that is this feasible, right? Because your recovery has to be from a place wherein it can actually recover from there, not from a place where that it cannot recover, right? Then you do the verification of the backup facilities. So you actually have a backup facility with you, and then you try to verify the things in and out, right? So how it's performing. Okay, and the next step is ensuring proper steps are documented to verify the compatibility of the backup facility. See, I've told you this earlier also that the documentation is very essential part. From the very first slide that I discussed at what exactly is the software, I told you it's a set of program along with the documentation. So if you do not do the documentation part, it is not a software, right? Even if can it can be, the documentation can be as small as a user manual or whatever, but without a documentation it doesn't fall into the category of being a software, right? And throughout my SDLC model also, and throughout my requirements testing, I have to let this stress onto each and every point that you need to document each and everything, because unless and until you document it, you are not, you actually like, there are people come and they go, like this is how it happens. The company develops the software, and the developers or the users, they come to the company, they leave the company, like this movement goes on to and fro, to and fro, to and fro. So due to all these things and all these measures, so taking this thing into account, because somebody can go and he can actually create the test cases, right? But if somebody else is like coming in after say 1 to 2 months of work, somebody was doing into a recovery testing, and then now somebody else came, and so the user would have no place, like where he's go, where, how will he proceed. So the documentation part is extremely important. You should always keep this thing in mind, right? Then you provide training within the team. So what you do, you train your team, and you provide a training kind of a mechanism into your team. Then you demonstrate the ability of the organization to recover from all critical failures. So what you do, you demonstrate your organization so that it can come out of all the critical failures, right? So you demonstrate it to people also. And then you maintain and update the recovery plan at regular interval, which is very, see, anything which is not maintainable is something not to be kept, right? So anything that can be maintainable and is supportive is the one that is of use. Okay, next we come to security testing. See, security testing is a type of software testing that needs to uncover the vulnerabilities of the system and determine that its data and resources are protected from possible intruders, right? So this is an entirely, I can say, you have a new subject in also cybersecurity, this security, that security, the IoT coming up, there's so many, like the internet security, the network security, you have so many cryptography you do, it's something that you really know. So your security is like, there's nothing that I can go ahead and explain anything extra in it, but your testing, security testing, will actually be the mechanism wherein you are testing the security parameters of the system, like how well it behaves, or in nobody can have an access. I can't say nobody, I would say unauthorized people cannot have an access to your data or your resources, right? Or to your system, or your software system that is being performed. So that is the very essential things of it. So, see, there are 4 main focus areas to be considered, especially in the while designing websites. And so, first comes the network security. So, this is network security. The name suggests from the vulnerability attack can be from the network side, right? So, you are not the one who are doing it, neither is anybody else who's doing it. Also, everything will be done from the network side, right? Then you have a system software security. So what it involves, that is accessing weakness in the various software. So you actually have various kind of system software, and these have a very weak points, I would say, from wherein anybody can venture into it and destroy, and can actually control your this thing. So that is the system software security. The client side application security, so this means that anybody cannot manipulate the client, right? So your client will also have this kind of a security mechanism. Say you can say, the very simple I can say is being protected by a password. That is the simplest one that we adhere to, right? So that's a client security, like client side security, the way of mechanism that you look after. Okay, server side application security, this is like one of the most worked on field, because nobody can venture into the, this is what happens in the WikiLeaks system. So wherein he leaked all the data from the servers, he took it from the internet, and then he did a blast blah, like, so he kind of opened up everything about everyone, and then the entire world was like, how do you have access to this data? So so you make sure that your server code and the technologies, these are robust enough to defend any kind of intrusion system, right? Okay, next we come to the stress testing. See, what is stress testing? So this is a type of software testing that verifies the stability and reliability of the system. So that it will look after the stability and reliability. So this test mainly measures the system of its robustness and error handling capabilities under extremely heavy load conditions. So you subject it to very heavy load, and then you see that how your system is performance, right? So this is done to make sure that the system would not crash under crunch situation. So what can be a crunch situation? See, suppose you have a traffic management system. So if it is a case of Kumbh Mela or Earth Kumbh Mela, so the entire system, how will it like proceed? So that much amount of traffic, whether it can take or not. Like WhatsApp, I can say that it is one of the most scalable kind of an app. Why? Because every day millions of users are being added into the database of the WhatsApp, but it is still accommodating very well. So that is one of the reasons I call it that. So that it is very reliable due to the load that it can handle, so much amount of load, right? So stress testing is done to make sure that the system would not crash under crunch situation, which we already discussed. It even tests beyond the normal operating point and evaluate how the system works under those extreme conditions. So this will stress means it will always be under pressure. You're constantly to be under pressure. It will always kind of stretch you beyond your limits to see that how you perform. So most prominent use of stress testing is to determine the limit at which the system or software or hardware breaks. Like, so at what limit the software, the hardware or the system is breaking. So that kind of a limit is known as a stress testing. It also checks whether the system demonstrates effective error management under extreme conditions. So you do an extreme condition and so how it is behaving to an error management kind of stuff. The goal of stress testing is to analyze the behavior of the system after a failure. So what you do, so after the failure you're analyzing the behavior, so how your system is performing. So for a stress testing to be successful, a system should display an appropriate and error message while it is under extreme condition. So it will show you an appropriate error message so that you know that what is actually the cause of its breakage. So this is kind of thing that we are looking basically into it, right? And the main purpose of stress testing is to make sure that the system recovers after failure, which is known as recoverability, right? So we already discussed recoverability testing, how it do. Okay, so what is the need? See, I told you discuss if it is a festive time like a Kumbh Mela or Earth Kumbh Mela or anything of that sort. So in this case, the shopping or the Diwali time at shopping, you have large amount of sales. Amazon shows this, shows that, shows. So and everyone like is giving so much kind of an offer and discount in festive seasons and during Christmas also. So at that kind, how your app is behaving, right? Say when a blog is mentioned in a leading newspaper, it experiences a sudden surge in traffic. So that is one of the things. See, suppose you have anything coming into the news and these still lockdown, people are usually sitting at home. So what they do is they scroll up and they look at all the news. So at most, the site which was not experiencing any sort of a traffic is actually receiving so much load that can it handle? So this is the very basic question, that can you perform? How do you perform under stress? So this is also extremely valuable for the following reasons. So what are the reasons? To check whether the system works under abnormal conditions, right? So how it is working under the abnormal sort of situation. Then you display appropriate error message when the system is under stress. So you see, like whenever the system goes into stress, so it's a proper message that has been flagged out to the user. So before going to that stress, it's actually flagging the error message and then it fails, right? So you do it like this was the reason of the failure. And the system failure under extreme condition could result into erroneous revenue loss. You can have loss into your system. So it is better to be prepared for extreme condition by executing stress testing. So it is like we told you, you should do it better beforehand, before the system breaks. Okay. So next last topic we come to, that is performance testing. See, performance is a non-functional testing technique that is performed to determine the system parameters, right? In terms of responsiveness and stability under various workloads. So how your system is behaving under various conditions and parameters, how it is performing. In stress, how it is performing. In speed, how it is performing. In reliability, in robustness, etc., etc., etc. Right? So performance testing measures the quality attributes of the system. What are the quality attributes? Scalability, reliability, and resource usage. time and like the memory consumption resource refers to, right? And what are the various performance testing technique? You have load testing, stress testing, which we already discussed, load we also discussed, soak testing and spike testing. So what's in load testing? Simplest form of testing conducted to understand the behavior of system under a specific load, right? And this results in measuring important business critical transaction and load onto the database, right? Application server, etc. Test is to find the upper limit capacity of the system and also determine the how the system performs the current loads goes well above the expected limit. So at the after it fails, so how it performs, like when it fails and how it actually recovers from there. Okay, soak testing. So this is known as endurance testing. So this is performed to determine the system parameter under continuous expected load. So continuously the load is kind of getting onto the system and due to the continuous load, so it is soaking everything. So that is where the testing name came from, right? So during soak test, the parameters such as memory utilization is monitored to detect memory leaks or other performance issues, right? The main aim is to discover the system performance under sustained usage. And what kind of a sustained usage? Your like a kind of a load usage. Sustained means so it is sustaining how well under that particular load. Okay, spike. See, soak was under a continuous load, and spike is like in between, like in the middle. Then it goes down. Then again it comes up into the middle. Then so abrupt phases, I can say. And this spike testing is performed by increasing the number of users suddenly by a very large amount and measuring the performance of the system. The main aim is to determine whether the system will be able to sustain the workload. Right? So this is how the process is do. You have a project assessment, you plan the test, you perform the test implementation, you analyze the result, then you identify if any retest is being done, and then again you plan, perform and analyze, or then you do a turn system and complete test, and you benchmark it after tuning, and then again you perform tests, so that it is not actually kind of this new thing has not introduced a new kind of an error. So that's how the cycle goes on, unless and until you see that this is performing very well. Okay, so the important questions are: what is system testing, what is recovery testing, what is security testing, stress testing, performance, types of performance testing, and process of performance testing. You have to explain. It can be types of your stress testing also, types of recovery testing also. I have done it in detail. Please look at the things in read it to just getting clarity of it. Thank you so much.